Okay, in this video we're going to talk about equilibrium temperature. And the equilibrium temperature is just the temperature that two objects will come to when put together. Because we know from experience that when you put a hot thing and a cold thing together, or really any two things that are different temperatures. So say I've got this water and it's at 20 degrees Celsius, and I put a block of something in here, and this is 40 degrees Celsius. We know that as time goes on, it'll eventually become one thing with all the same temperature. And we know again from experience that energy is transferred from the hot thing to the cold thing. So now maybe they're both at, I don't know, let's say like 25 degrees Celsius. And this would be their equilibrium temperature. Remember that heat is transferred between two objects until they have the same temperature. This is for something like conduction, right? And that once they're the same temperature, there will be no more net flow of energy. They can still exchange energy, but there's equal amounts in going out. So this might give energy to this, but this will give energy to this. And we can use a simple conservation of energy argument to find a formula for the equilibrium temperature. And all I have to do is say that M1C1 T1 plus M2C2 T2 divided by M1C1 plus M2C2 is my equilibrium temperature. And this T1 is the initial temperature of your first object. Initial temperature for your second object. And the way that we get that equation is just from noting that MC delta T, remember, is Q. Well, if I have the Q of object 1, so I'll call it M1C1 delta T1, that plus the Q of the second object, M2C2 delta T2, has to equal 0 joules. And all I'm saying is that any energy that is gained by the cold thing must have come from the hot thing. And any energy that the hot thing loses must go to the cold thing. Right? So in essence, I'm saying that the energy transferred by the first one plus the energy transferred by the second one is equal to 0. And that's because one of these is going to be negative. And that negative sign just means that it's losing energy. So the one that's losing energy is giving that amount of energy to the other one. So again, it'll come out to 0. And then if I just algebra this equation around, and I remember that the final temperature is going to be the same for both. It's going to be the equilibrium temperature. When I algebra it, I'll get this equation. Okay? And now it really is just a plug and chug thing. And just one thing to note is that this M1 and this M1 and this C1 and this C1, they don't cancel out. This M2 and this M2 and this C2 and this C2, they don't cancel out. And what you do is you have to plug this into your calculator, put a left parentheses when you open it, do M1 times C1 times T1 plus M2 C2 T2, close that parentheses, then do divided by, open parentheses again, M1 C1 plus M2 C2, close parentheses. And that will give you your equilibrium temperature. And just one thing to remember is that if I have an object with a really high specific heat, the equilibrium temperature will be closer to the temperature of that object than the other object. And if you want a more thorough explanation for that, you can look on the study guide. But that's one thing to check your understanding of equilibrium temperature.